Alright guys, here are the solutions to the chapter review. You can see in the first section here I have color-coded the equation with the line, so take a look. Hopefully these are right. When I go over them, I will not miss them. Alright. Again, hopefully all of these are correct, and when I go over them, I'll make sure they're correct. That was a tough one. You can see there the only line I shaded was the green one, and then I went ahead and shaded all of them at the end. I'm above the green, below the black, to the right of the blue, and to the left of the red, which puts me in that little square. Alright, let's work through them. So this first section, I am solving each system by graphing. I want to graph the two lines and name the point they cross at. So in this equation, the y-intercept is 4 and the slope is -1. So I'm going to put a dot at 4. I'm going to go down 1, right 1. Or instead of going down and to the right, I could go up and to the left. And there's that line. This equation has a y-intercept of 12. It has a slope of 3/1. So I'm going to put a dot at the y-intercept, which is 12. And I'm going to go up 3, right 1. But I can't really go up and to the right, so I'm going to go down and to the left. And that puts me crossing right there. And that solution would be the ordered pair -2, 1, 2, 3, 4, 5, 6, -2, 6. I could check that quickly, but I'm pretty sure it's right. Number 2. This equation is already in slope-intercept form, so I would have a y-intercept of 3 and a slope of 2/1. Therefore, to graph it, I'm going to put a dot at 3. I'm going to go up 2, right 1, or down 2, left 1. And that line is going to look like that. The other line is not in slope-intercept form, so I might start by subtracting x from both sides, and then dividing by -3, giving me y equals -2 plus 1/3 x. So that one has a y-intercept of -2 and a slope of 1/3. So I'm going to put a dot at -2 on the y-axis. I'm going to go up 1 and right 3, or down 1 and left 3. And it looks like my point would be at -3, -3. The third one. This one is already in slope-intercept form. It's got a y-intercept of 1. It's got a slope of 1. So I'm going to put a dot on the y-axis at 1, and I'm going to go up 1, right 1, or down 1, left 1. The other line is not in slope-intercept form. So the first thing I would do is subtract 2x from both sides. Then I'd go ahead and divide everything by -2. And I would end up with y equals 1 plus 1x, right? -2 divided by -2, +1. So that one has a y-intercept of 1 and a slope of 1. And it turns out that that is the same line that I already had graphed. So since those are the same line, every point on the line is a solution, and there are infinitely many solutions. We are now solving by substitution. Number 4 is a nice problem because the y is already by itself. I can take what y equals and substitute it into the other equation. So instead of 2x plus y, it's going to be 2x plus x minus 7 equals negative 21. Adding my like terms together, I get 3x minus 7 equals negative 21. Adding 7 to both sides, I get 3x equals negative 14. And dividing by 3, I get x equals negative 14 thirds. Substituting that in back to the first equation, I get y equals negative 14 thirds minus 7. That would be negative 14 thirds minus 21 thirds if I turned the 7 into a fraction over 3. And that would be negative 35 thirds. So y is negative 35 thirds and x is negative 14 thirds. Number 5. I would take what y equals and I would substitute it into the other equation in place of the y. So when I rewrite this other equation, it's going to be 3x minus, I've lost the board for a second. Hopefully it'll come back to me. I'm going to have 3x minus, instead of 3 times y, it's going to be 3 times x minus 7 equals 21. Simplifying this by distributing the 3, I would get minus 3x and I would get plus 21 equals 21. And combining my like terms, the 3x minus 3x actually cancels out. I get 21 equals 21. Remember, when the variable cancels out of the problem, it's either no solution or infinitely many solutions. Because these two things equal each other, that tells me that this one is infinitely many solutions. Number 6. I'm supposed to solve by substitution. So I guess the first thing I would do is over here I would add y to both sides so that the x is by itself. X is equal to 3 plus y. And now I can take what x equals and I can put it into the other equation in place of the x. So instead of 3 times x, I'm going to have 3 times 3 plus y minus y equals negative 13. That gives me, when I distribute that, I get 9 plus 3y minus y equals negative 13. When I combine my like terms, I get 9 plus 2y equals negative 13. I would subtract 9 from both sides and get 2y equals negative 22. And when I divide by 2, I get y equals negative 11. So I can go ahead and substitute that in the first equation, and x would equal 3 plus negative 11, which would be negative 8. So x equals negative 8, y equals negative 11. I think I'd like to check that. In this equation, that would be negative 8 minus negative 11 equals 3. That's true. And in the other equation, I would have, in this equation, I would have 3 times negative 8 minus negative 11 equals negative 13, and that's also true. So that is the correct answer. All right, now I'm supposed to solve by elimination. So if I was going to solve by elimination, I would leave this equation alone, but I would multiply this equation by 2, giving me negative 4x, positive 12y, and 18. And then I can go ahead and add these together, and the x's will cancel, and I get 13y equals 39. Or, of course, if I go ahead and divide by 13, I get y equals 3. And I would probably substitute that back into the first equation and get 4x plus, instead of plus y, I'm going to use plus 3 equals 21. I would subtract 3 from both sides and get 4x equals 18. And then I would divide by 4 and get 4.5. So my solution here is x equals 4.5, y equals 3. Number 8, I'm going to cancel out the y's because they already have opposite signs, but you could cancel out the x's. To cancel out the y's, I would multiply this one by 3 and this one by 4. So I'd get 15x, I'd get 12y, and 3 times 83 is 249, negative 249, I think. The second equation by 4 would give me 12x, negative 12y, and negative 48. So when I then add those together, the y's would cancel out. I'd have 27x, and here I'd have negative 297. And if I go ahead and then divide by 27, I get x equals, and I think that's negative 11. And I would probably substitute that back into the, I don't know, first equation, I guess. So 5 times negative 11 plus 4y equals negative 83. That'd be negative 55 plus 4y equals negative 83. Adding 55 to both sides, I would get 4y equals 65, 75, 83. That's a yucky number, is that right? 28, it is, negative 28. And then if I divide by 4, obviously I get negative 7. So my answer is x equals negative 11, y equals negative 7. Last one of these, I would go ahead probably and multiply the first equation by negative 5. So that would give me negative 5x, negative 10y, and negative 115. And the second equation, I would just leave it as is. And you see here that immediately the variables are the same thing, so they're going to cancel out. When that happens, you need to put in the 0. I know normally we don't write the 0 in, but if everything cancels out on one side, you got to put the 0 in. And on the other side, it looks like I have negative, what is that, 60? So when the variables cancel out, you're done. It's either no solution or infinitely many solutions. Because these two things do not actually equal each other, that is what tells you that this problem is no solution. All right, this brings us to the inequalities. So this one is already in slope-intercept form. It's got a y-intercept of negative 4, and it's got a slope of up 2, right 1. So I'm going to go up 2, right 1, up 2, right 1. Because of this symbol right here, there's no or equal to, so it's a dashed line. And if I put 0 in, I'd have 0 is greater than negative 4, which is true. So I'm going to go ahead and shade the side 0, 0 is on. This one is already in slope-intercept form. It's got a y-intercept of 2. It's got a slope of -1. So that's down 1, right 1. Or up 1, left 1. Because it's got an or equal to, it's going to be a solid line. And if I put in 0, 0, 0 is less than or equal to 2. That's true, so I'm going to shade the side 0, 0 is on. And you can see that this area in here, to the left of the red and under the blue, is my double shaded area, right? We go to problem 11. Problem 11 is not in slope-intercept form. If I were to put it in slope-intercept form, first I would subtract 2x from both sides. And now this is the big thing, maybe, if you're shading by using the symbol. If I divide by -1, I get y, but you got to remember, since you divided by a negative, you got to flip the inequality, and you get y is less than 2x. So this has a y-intercept of 0 and a slope of 2. You'd put a dot at 0 and go up 2, right 1, or down 2, left 1, down 2, left 1. It would be a dashed line because it's not or equal to. And because it is less than, I'm going to shade under the line, which would be this side. This equation is also not in slope-intercept form. So I might start by subtracting 3x from both sides. That would give me -14 minus 3x. And then divide everything by 2. And I would get y is less than or equal to -7 minus 3 over 2x. So the y-intercept would be -7. And the slope would be -3 over 2, which is down 3, right 2, or up 3, left 2. This would be a solid line because it's got or equal to. And if I go back to the original problem and I put 0, 0 in, I find out that 0 plus 0 is less than -14. That is false. So the answers are not on the side of 0, 0. They're on the other side of the line. And that makes my double shaded area this little triangle down here. Right? That brings us to the story problems. Ha! All right. This first one says that the owner of a hair salon charges $20 more per haircut. That's going to be one of our sentences, I think, than the assistant. Yesterday, the assistant gave 12 haircuts, and the owner gave 6 haircuts, and the total earnings was $750. How much does each person charge? So, in green, the question, how much does each person charge, that's where I'm going to set up my variables. I'm going to have x be owner, I guess dollars the owner, charges. And I'm going to have y be dollars the assistant charges. Now, the red line represents one of my equations. It says the owner charges 20 more than the assistant. So that means the amount the owner charges equals the amount the assistant charges, but they're not equal, right? The owner charges $20 more, so to be equal, we would have to add 20 to the assistant. The owner charges the assistant's amount plus 20. And then the blue underline is my other equation. And that would be when the assistant gives 12 haircuts. So 12 times y would be the cost of the assistant giving 12 haircuts. And the owner gives 6 haircuts. So 6 times X would be the cost of 6 haircuts by the owner. The total amount is $750. So there's an equation that deals with all the costs. And I would probably solve this one by substituting what X equals into the other equation for X. So over here I'm going to write 12y plus 6 times X, which is y plus 20, equals 750. When I simplify the left side, I get plus 6y plus 120. And when I add my like terms together, I get 18y plus 120 equals 750. When I subtract 120 from both sides, I get 18y equals 630. And finally, of course, I would divide by 18. And when 630 is divided by 18, I get 35. I get y equals 35. Now I would take that back up here, and I would say x equals 35 plus 20, or x equals 55. And then I'm not going to write the therefore statement again. I already wrote it in the answer key. But the owner charges $55, and the assistant charges $35, right? Number 17. It takes a florist 3 hours and 15 minutes, or 195 minutes, to make 3 small centerpieces. 195 to make 3 smalls and 3 larges. It takes 6 hours and 20 minutes, or 380 minutes, to make 4 small and 7 larges. And then the question is, how long does it take to make each small and each large? So again, the green is my question, and 95% of the time you want your variables to be the answer to the question. So I'm going to have x be minutes to make a small centerpiece, and I'm going to have y be minutes to make a large centerpiece. And then again, I have color-coded the equations. When I make 3 smalls right here, right, 3 smalls, that means it would take 3 times x to make 3 smalls, right? That's how many minutes it would take to make 3 smalls if it takes x to make 1. And 3 larges, so that's how many minutes it takes to make 3 smalls and 3 larges, and that's 195 minutes. And you've got a similar equation with the blue. 4 smalls and 7 larges takes 380 minutes. And so now you've got a system of equations. You can go ahead and solve it. I would probably solve it by elimination, and I'd probably eliminate the x's. All right, so I'd probably go ahead and multiply this first equation by 4, giving me 12x, 12y, and 780. And I'd probably go ahead and multiply this equation by -3, giving me -12x, -21y, and what is that? 900 and another 240 is 1,040, -1,040. And then I can add these together, and I get gone, -9y, and what is that? 880, 980, 260, -260? -260? Let's see if I like that. I'm not sure I like that answer. What have I done wrong? I better check my calculations. Let's see, 195 times 4, 780, 380 times 3, 1140, negative 1140, my bad. So, oops, there we go. This is going to be negative 1140. That's what I get for trying to do everything in my head. So when I add those together then, 880, 980, 1080, 360, negative 360. And then when I divide by negative 9, I get y equals 40. And I would probably go ahead and plug that back into this equation. So I would get 3 times x plus 3 times 40 equals 195. That'd be 120. That would be 3x. If I subtract 120, I get 75. And if I divide by 3, I get 25. So again, I'm not going to write the therefore statement again, but 25 is the number of minutes it takes to make a small, and 40 minutes is the number of minutes it takes to make a large. All right, we got Neomon. Has recently learned he can fly. All right. I guess we can go ahead and color code this. Let's see. With the wind at his back, he was able to fly 510 miles per hour. Against the wind, 402 miles per hour. Flying speed in still air and speed of the wind. Okay, so I'm going to make x equal, right? These are always the same. X is the speed of the object. So x is his speed in still air. And y is always going to be the speed of the force acting on the object. In this case, that's the wind. Speed of the wind. And with these motion problems, the equations are always the same. With the wind at his back, that means he can fly however fast he can fly, plus the wind speed gives him a speed of 510 miles per hour. And then when he's coming home against the wind, that would be he's still flying as fast as he can fly, but now against the wind I have to subtract the wind speed, and that gives him 402 miles per hour. And of course, these are the easiest kind to solve because they are perfectly set up for elimination. I can go ahead and add these together, and the y's cancel themselves out. And this would be 912. And if I divide both sides by 2, I find out that x equals 456. And if I go ahead and plug that back into the first equation, 456 plus y equals 510. Then I can subtract 456. And I would get y equals 44 plus 10, 54. So once again, I'm not going to rewrite the therefore statement, but x is how fast he can fly, which is 456 miles per hour. Go Neomon, that's pretty darn fast. And he's flying through what looks like almost a hurricane. Wind speeds of 54 miles per hour. That's pretty good. All right, that takes us to, I feel like I skipped one. That takes us to the lemonade problem. Ryan is mixing together 2 types of lemonade. All right, so let's see. He mixes together the Meyer lemonade, which is too bland, it is. It's only 32% real lemon juice. So you got the Meyer, which is 32% lemon juice. And then you got the concentrate, which is 94% lemon juice. And, you know, that was not right. Let's go back and do that again. The juice from concentrate is 98%, and he wants to make a mixture that is 54%. So all that represents one equation. All the percents represent one equation. And then he's trying to make 128 ounces. That's the other equation. And how much of each one he should use would be his variables. So X will be the ounces of 32% juice, and Y will be the ounces of the, 94% juice. And my first equation, this blue one, I know when he mixes these together, when he mixes these ounces and these ounces together, they need to add up to 128 ounces. So that's the easy equation. And then the harder equation deals with the percents. I know that the X is 32% juice, so 0.32 times X is the amount of real lemon juice in those ounces. And the 0.94 Y is the amount of lemon juice in those ounces. And don't forget the 0.54 times 128 is the amount of juice in the mixture. And now I'm ready to go ahead and solve this, but I'm going to need to figure out what is 0.54 times 128, and that turns out to be 69.12. So, oops. I know some of you like to do this by substitution, some by elimination. I'm going to do it by elimination because that's the method of my choice. I'm going to take this first equation and multiply it by negative 0.32. So that would give me negative 0.32x, negative 0.32y, and whatever negative 0.32 times 128 is, that is negative 0.4096. And now I'm ready to add these equations together. The x's are going to cancel out. The y's are going to be 94, 92, 62y. And 6912 minus 4096. 6912 minus 4096 is going to be 2816. And of course I can finish it off by dividing both sides by 0.62. And I get 45.4. I went ahead and rounded to the nearest tenth. So I certainly would then I go back and plug it into this one and have x plus 45.4 equals 128. And if I go ahead and subtract 45.4, 128 minus 45.4 gives me 82.6. So there's my answer. Again, I'm not going to write the therefore statement again. You've already seen the therefore statement. But I would be using 45.4 ounces of the concentrate that is 94% juice. And I would be using 82.6 ounces of the Meyer lemonade that is 32% juice. All right, that takes us to Grace and Peyton going to the zoo, right? They saw the opening of elephants and ostriches on display. Quite the display, I might add. It was a wildlife exhibit. All right, here we go. They noticed that counting the elephants and ostriches, there were 32 heads and 88 legs. All right. You know what? That's not quite what I want to do. There we go. How many elephants and ostriches were on display? All right, so again, my question is how many of each? So that's going to be my variables. I'll have x be the number of elephants, and I'll have y be the number of ostriches. All right. Well, here's the deal. Because there's 32 heads, I know that the number of elephants and the number of ostriches adds up to 32, because they've all got one head. So the number of elephants plus the number of ostriches adds up to 32. Now, there's 88 legs. Okay, so that tells me, let's see, elephants have 4 legs. So however many elephants there are 4 times that many legs. And ostriches have 2 legs. So I don't know how many ostriches there are. There's Y of them. And 2 times Y would be all the ostrich legs. And when I add those together, I get the total number of legs, which is 88. I'm now ready to solve this. Again, I would solve by elimination. I'd go ahead and multiply this first equation by -2, giving me -2x, -2y, and -64. And now I can add my 2 equations together, and I can get 2x, the y's are gone, 88 minus 64 is about 24. And obviously now if I divide by 2, I get x equals 12. And shockingly, I'm going to use this equation to figure out the other variable. 12 plus y is going to equal 32. And if I subtract 12 from both sides, I'm going to get 20. So, again, I'm not going to write the therefore statement again, but you've already seen it. There would be 12 elephants, and there would be 20 ostriches on display. All right, that takes me to vocabulary. Not sure I need to go over this since I already kind of went over it on the answer key, but these two refer to whether there actually are solutions or not. When a system is consistent, it means there are solutions. And when a system is inconsistent, that tells you there are no solutions. All right? Now, when there are solutions, it's also one of these. When there are solutions, you might have a dependent system or an independent system. A dependent system means that they are the same lines and there are infinitely many solutions. And an independent system means you have 2 lines that cross, which means there's one solution. So, with that in mind, if a system has one solution, that means there are solutions, so that would be A, and there's one solution, so that would be D. For letter B, again, there are solutions, so that would be A. And this time there's infinitely many of them, so that would be C. And then last up, a system has no solutions. That means it's inconsistent. That would be B. And that takes us to the last one. Oh, mercy. Here we go. All right, so the first thing I need to do is I need to notice that grams of silver is my x value, because it's on the x-axis. And grams of gold, not sure I put it there, but grams of gold would be my y value. And I'm trying to make a ring, apparently. And this ring is going to have some silver and some gold in it, right? And there are 4 restrictions to this ring, and I color-coded it, and I can't remember what color I used for each one. I guess I could look, but it doesn't really matter. Here's one of my restrictions. The total must be more than 10 grams. So the grams of gold, or the grams of silver, plus the grams of gold need to be less than 10. When I graph that, I would go ahead and use the x and y intercepts. That has an x-intercept of 10, which is right there. It has a y-intercept of 10, which is right there. And if I connect those, it's going to be a dashed line because it's just less than. And there's that line. Now I'd want to decide which side to shade of that line. So, I made a mistake already. I'm so sorry. I need it to be more than 10 grams, so it's going to be greater than 10. And so now when I shade that line, I'm going to put 0, 0 in for x and y and find out 0, 0 is false. So I'm going to be shading this side of the line, right? I don't want to shade the whole thing. It'll make the graph look really messy. All right, my next restriction is that this ring has to weigh less than 20 grams. I mean, who wants that heavier ring on their finger? Jayla? I don't know. So this time the grams of silver plus the grams of gold need to be less than 20. All right, if I was going to graph that, I would again use the x and y intercepts. The x-intercept is 20, so that's right there. The y-intercept is 20, and that's right there. This is also a dashed line. Would look like that. Kind of. A straight edge would be really handy here. And this time, when I go to shade it, I put in 0, 0, right? I put in the origin. And 0 plus 0 is less than 20. So this one's going to be shaded on this side of the line. So right now I'm shaded between the red and the blue. My next one is that the ring must contain at least 2 grams of gold. So that's the y value. The y value must be greater than, and at least means greater than or equal to 2. Well, that's an easy line to graph. Y equals 2 is a horizontal line, and it would be a solid line. And it would look like that. And this would be shaded, let's see, 0 is greater than 2 is false. So when I plug 0 in, it's not an answer. This one's going to be shaded above the line. So now I am inside the red and the blue and above the green. And that brings me to my last restriction, the cost. The cost has to be less than 90. Well, the silver cost 40 cents per gram. So 0.40 times y, not y, let me say that again. 0.40 times x would be the cost of all the grams of silver that I use. The gold is $25 per gram, so 25 times y would be the cost of all the gold that I'm going to use in this ring. And when I add those costs together, they have to be less than 90. So again, I went ahead and figured out, to graph this, I figured out the x and y intercept. The x-intercept is 90 divided by 0.40, and that turns out to be 225. So I went ahead and put a dot on the x-axis at 225, which is right there between 220 and 230. See it there? And then the y-intercept would be 90 divided by 25, and that turns out to be 3.6. So So I put a dot on the y-axis at 3.6. That is 2, 3. It's halfway between 3 and 4, a little closer to 4. It's right in there. See the dot I can make? And then if I had a straight edge, I would draw it with my straight edge. This is going to be a dashed line, and I'm going to connect the two black points. And so it's going to look something like that. And what that gives me is a little a little red area I made. I guess I should have said the black line is shaded below, because if I put 0, 0 into this equation, it is true. 0 plus 0 is less than 90, so I'm shading below the black line. And all of this gives me this little rectangle right in here. That is the possibilities for grams of silver. So the grams of silver needs to be kind of between 10 and 20. And the grams of gold needs to be between maybe 2 and a little more than 3. So I went ahead and picked a point that I was sure was in there right about here. I picked the point 10.3. And so I said, all right, let's use 10 grams of silver, 3 grams of gold. That fits all the restrictions. And I had to calculate the cost of that ring. So 10 grams of silver cost 40 cents each, and 3 grams of gold cost $25 each. And that turns out to be 4 plus 75, or $79 would be the cost of that ring. All right, I hope that helps. If there's anything I can do for you, text me over the weekend, and let's get ready for this test on Monday.